Hello students. In this video we want to continue our discussion of algorithms and look at a very particular set of algorithms that are very useful for computers and just daily life in my opinion. Okay, but first a challenge for you. Okay, I'm going to show you a list of 50 words. Okay, and your goal is to sort them in alphabetical order as fast as possible. Okay, I'm going to give you 3 minutes. I want you to see if you can do it. Okay, this is your challenge. So I'm going to show the list, write it down on paper, see if you can put in alphabetical order as fast as possible. Okay, ready, set, go. Get the 3-minute timer going. Okay, I'm just going to go ahead and step out for a second. Okay. How'd you do? Were you able to get them all? So this is, this is one of the reasons I like to talk about this problem, and what we're going to talk about today with sorting algorithms. Is a lot of students make the mistake of trying to do this in alphabetical order to start. So they'll go through the entire list, try to find the first word they see and see if it's the first one. So maybe they see arrest over here, or apathetic, or army, and then they're like, okay, apathetic's first, so they'll put apathetic, and then they'll go through the list again until they get the next letter, and then the next letter, and then they'll go through the list again for B, and they try and do it exactly in order the first time. And if you do that, it's really slow. And if that was the process you were following, it probably didn't work. Okay, you probably weren't able to do it in time. However, if you do this in a different way, if you use a different algorithm for sorting, you may have been able to solve this. So for example, what I do when I solve this problem, I'll just open a blank document here, is instead of going through the word list every single time, I just try and put each one by letter first. Okay? So if I was looking through my list, I'd start with the first word seen. I'd put, okay, hurried is right there. Okay? Let me see if I can increase the size of this a little bit. There we go. And then I'd say, well, okay, cough is up in the C's, so it's up here. And then edge is around there. And, grass is around there. Okay? And I go down. T's, okay, that's in the T's. So trade, go down there. Truculent, I don't even know what that means. Okay, is down there. Okay, and you don't really worry about ordering them too much, just getting them in the right spot first, so just by letter. Okay, entertaining's around E. Okay, if I could spell. Now, obviously, I have a keyboard, so this is probably helping a little bit instead of doing it on paper. But if you just do letters first, then you get all the things in kind of the right spot, and then you just have to sort a few words instead of the whole list every single time. Okay? So if you use that process, you can actually do it in under 3 minutes. Okay? So using a different algorithm for sorting actually makes it better. Okay? And faster. So this is what we want to talk about today, is a specific group of algorithms called sorting algorithms. How can I take a list of words or numbers, whatever it is, put them in order really, really quickly? Okay? Computers need to do this, again, all the time. All your files on the computer need to be sorted so we can search through them quickly. In the elevator problem, we need to sort the people in order to send them up the elevator correctly. Your computer actually does this for completing tasks. It actually prioritizes certain ones and sorts them based on what's most important. Like, is it most important to keep my screen up to date on the computer, or is it more important to run something in the background, or is it more important to run this video that the person wants to watch, etc. So it does sorting algorithms with priority and other things like that. Okay, so it turns out there's actually lots and lots of sorting algorithms out there. Okay, so if you wanted to sort some numbers, for example, it turns out there's a lot of ways you can do it. And I put a video on Canvas that actually shows the different ways you can sort the numbers. Okay, so make sure to watch that. It's a really cool video that shows how you would take the different heights represent kind of the different numbers, and it shows different ways you can sort those numbers quickly. Okay, so make sure to watch this. It's really interesting, really cool to watch. And some of them are faster than others. Okay, they just are, because it's more effective to sort. Okay, but again, let's focus on some numbers. Okay, so let's say I had the following numbers to sort. Okay, I actually used to work for my uncle, and his product had a bunch of number IDs on them. So all the time I would actually take out the product, look at it, figure out the ID, and sort it in a big box with all the other ones. Okay, so I had to sort all IDs all the time. So this is actually an example where I use this in the real world. Okay, let's say I have 8, 4, 3, 7, 9, 2, 5. Okay, and these are my numbers. I'm trying to sort them quickly. Okay, well, you probably can put these in order pretty quickly, right? You can look through the whole list really fast and see that 2 is the smallest, then 3, then 4, then 5. Okay, but imagine this list is thousands of numbers long. Okay, then going through the whole list every single time is gonna not work, right? So here's what we want to talk about today, and one of the most common tricks is just to sort a smaller group of numbers. Okay, so let's just sort these 3 on the left, and then let's sort those 4 on the right. Okay, so if I sort these 3 on the left, I get 4, 7, 8. That's not hard. I can easily sort 3 numbers. And the 4 on the right is 2, 3, 5, 9. Okay, well, if I have 2 sorted lists, it's now really easy to combine them, because all I have to do is look at the first number and say, well, which one of the first numbers is bigger? Well, this one's bigger, so that will go first. And then which one's bigger, this number or this number? Well, this one's bigger, so that one will go next. Okay, which one's bigger, that number or that number? Well, this one's bigger, so I'll put that one next. And then this number, right, that number, that number, etc. Okay, so even if you have a list that's thousands or even millions of numbers or IDs long, you can sort it really fastly if you break it into smaller lists. Okay, and this is the exact idea behind merge sort. Okay, so again, just a fancy algorithm name, but I've actually used this before when I was grading as a TA for a class that I was TAing for. The key is to break it into smaller lists, sort the smaller lists, and then merge them together. Okay, so actually what happened in that class is I had a whole bunch of tests I graded, but I wanted to pass them back in alphabetical order, but they were all mixed up, right? So instead of, okay, go through the whole stack of papers, this is the first letter, go through the whole stack of papers, here's the next letter, I just broke it into a whole bunch of little stacks and then started sorting those together. Okay, so that's a key idea and something you can use to help with sorting in general. Okay, another way you could have done this list problem is just sort each column and then combine the columns. Okay, that's another way you can do something like that. Okay, it really makes it a lot easier to see. Okay, but let's practice one more example of this merge sort and go through the steps of how you would do it. Okay, and again, I know it's easy to sort a few numbers. You can do that by going the old way, but I want you to understand that this algorithm extends much better than our traditional thinking does. Okay, something that may be intuitive to you is probably not the most effective for a computer. Okay, or it may not be the most effective in every case. Okay, it's what we call, it doesn't scale. It may work in the small example, but doesn't scale to a really big example. Okay, but merge sort does scale to really, really large examples. Okay, so let's look at this one. Okay, so let's say we're a computer, we need to sort these numbers. Okay, so the first thing the computer does is officially it breaks the list in half multiple times, but really all that matters is it sorts it into groups of 2. Okay, so it's going to try and sort 49 and 42. It's going to try and sort 31 and 75. It's going to try and sort 97 and 64. Sorry, those numbers are kind of spread out weird. Let's try that again. There we go. And then it's going to try and sort 88 and 15. Okay, so sorting 2 numbers at a time is really easy. Okay, 49 and 42, that's easy. That's 42, 49. 31 and 75, well, that's already in order. 31, 75. 64 and 97, well, let's order that. 64, 97. 15 and 88, we want it in that order. Okay. Now what it's going to do is it's going to merge the 2 closest lists to each other. So these 2 are closest and these 2 are closest. Okay. Or I should say, it's these 2 and then these are the next 2 available, etc. Okay, so now let's just sort these ones. These are easy to merge. Okay, which one's bigger, 31 or 42? Well, 31 is. Then 42 is next biggest. Then 49, and then 75. Okay, this one was first. Then that one. Then this one. That one. Okay, let's sort this one. Okay, 15 versus 64. Well, 15's smallest. 64 versus 88. Well, 64 is next smallest. 88 or 97. Well, 88, and then 97 is our biggest. Okay. Now, last step, we need to we need to merge these 2 lists until we have our full list. Okay. Which one's smaller, 31 or 15? Well, 15 smaller. 31 or 64, 31. 42 or 64, 42. 49 or 64, 49. 75 or 88, 75. 88, and then 97. Okay. Okay, so that is what merge sort looks like. Okay, I'm going to split it up into multiple lists, sort those smaller lists, and then merge those lists together. Again, you could have done this probably pretty quickly without merge sort. But again, the process itself is something that's important for getting much, much larger lists organized. Okay. All right. So again, a visualization. Take each smaller list, each smaller group. Okay. sort each smaller group, merge groups together, and keep repeating that process until you have the full list merged together. Okay? So that is merge sort. And that's one of the ones you're going to practice on your homework. Okay? Split it up into small lists, 2 preferably. Sort those smaller lists, merge the lists together. Okay? All right. So we've talked a lot about algorithms, but hopefully this is giving you appreciation for how to think like a computer, right? Our goal is to eventually get to programming and be able to think about algorithms effectively as a key component of programming. Okay? How do I tell the computer how to sort something? How do I tell the computer how to do something? So having well-defined algorithms will be key to solving those problems. Okay? All right, we'll talk about data in the next video, and I'll see you guys then.